Good day everyone. Today we will try to do some exercises or AVR Studio programs, and it is in relation with our midterm laboratory exam. So let's jump up to the video. In this part, you already know the drill, how to create the file, store their location, and as well as to choose the devices platform. And as you can see, this is our problem, and this is the problem that we are trying to solve later on. And I had already pasted the code, and from the upper part is the loading of values, and from the lower part is the adding of values. And as I try to assemble the code, as you can see, it is successful, and we can now proceed with our debugging mode. And let's assemble and run this code. So now we are in the debugging mode. So let me just adjust some things, and let me fix the layout of our IDE. So this is our status register, as you can see. So we can also see our flags in here, and we can also see our C, Z, and H flags that we are about to monitor. So let's use the single step to examine the code. In the LDI command instruction, we are just loading values into the register, so there will be no significant changes with our flags as well as in our status register. So let's just take a look with our register if we had successfully loaded the values. So as you can see, here are the values that we had loaded to our certain registers. So now we are about to mentor our status registers, also the flags. So for the first step of our add instruction, there are no significant changes with our flags, as you can see. The C flag turns 1 when the resulting value of the previous instruction is exceeding the 8 bits. And referring to the bitwise operation on the table below, the resulting value or the rest one is not exceeding with 8 bits. That's why the C flag is 0. The H flag turns 1 when the lower nibble of the resulting value of the previous instruction is exceeding the 4 bits. And as you can see from the bitwise operation below, the resulting value is not exceeding or does not have carry in the lower nibble. That's why the H flag is 0. Lastly, the Z flag turns 1 when the resulting value of the previous instruction is resulting to 0. And on our first single step, the resulting value of the addition of R16 and R17 does not equate to 0. That's why the Z flag is equal to 0. Now, let's take another step with our second add instruction. And as we can see, there is a change with our C flag. The C flag has a value of 1. This only means that the resulting value of the previous instruction is exceeding to 8 bits. Now, let's move on with our third add instruction. And as you can see, the resulting value from the previous add instruction doesn't give any significant changes with our flags. By looking at our status registers, the V and N flag had only significant changes. Now, by stepping to our last add instruction, we can obviously see that the value of the C and H flag has been turned to 1. Meaning, the resulting value of the previous instruction is exceeding the 8 bits, and the resulting value of the lower nibble of the previous instruction is exceeding 4 bits. And maybe that's all with our flags. So now we can proceed to our registers and see the values of each registers. With the help of the LDI instruction, we are able to load the 5 values into the specific registers that we are assigned to. And that's all for this first activity, and see you on the next activity.